Okay, this lesson is to help you study for quiz 3, and it's about factoring completely. So all of the rules that you have found for factoring are going to kind of get put into a big pile, and you can use which ones you need depending on the problem that they give you. So I'm going to run through some examples to kind of help you with these. The first one says find the GCF. Let's try to write a little better if I can. Between two numbers, so 240 and 360. Now, one of the ways that we can find the GCF, which is the greatest common factor, is we can list all of the factors for 240 and list all of the factors of 360 and then figure out which is the biggest one. But seeing as how these are big numbers, we want to have some sort of strategy that might help us to do things a little bit easier. So you're going to use prime factorization. And again, we're looking for the biggest number that goes into both. So if we look at 240, we need two numbers that multiply to 240. So we could choose 24 and 10. Again, doesn't matter which ones you pick as long as the two numbers do multiply to 240. Now we look at what numbers multiply to 24. So I'm going to use 6 and 4. You could have used 8 and 3, 12 and 2, doesn't matter. 6 is 2 and 3. Now those are prime numbers, so those ones are keepers. 4 is 2 and 2. So again, those are prime numbers, those are keepers. 10 is 2 times 5, and so those are prime, and now they're keepers. So what we can redo, or rewrite rather, 240 as 2 times 2 times 2 times 2. Notice there's 4 2's there. Times 3 times 5. So that would be its prime factorization. Now sometimes they like to write this using exponents. So that could be 2 to the 4th times 3 times 5. Either way works. Now 360, we want to do the same thing with 360. So two numbers that multiply to 360. So I'm going to use 36 and 10. 36 is 6 times 6. Again, doesn't matter which numbers you pick. 6 is 2 and 3. We want to keep those. 6 is 2 and 3. We want to keep those. And 10 is 2 times 5. So 360's prime factorization is 2 times 2 times 2. Notice there's 3 2's. Times 3 times 3. Notice there's 2 3's. Times 5. Or we could say that that's 2 to the 3rd times 3 squared times 5. Now we want to compare these two prime factorizations, because how do we use this to get the GCF of these numbers? So what we do is we want the product of all the common primes. So we have 2 to the 4th times 3 times 5 versus 2 to the 3rd times 3 squared times 5. So we look for the ones that are in common. So they have a 2 in common, but how many 2's do they have in common? They have 2 to the 3rd in common. And then we look at the 3's, and they have a 3 in common, but only one of them. And then they have a 5 in common, and again, only one of them. So this is the GCF, 2 to the 3rd times 3 times 5. Now all we have to do is multiply. So 2 to the 3rd is 8, because that's 2 times 2 times 2, times 3, and then times 5. And our answer is 120. So that's the biggest number that goes into 240 and 360. Next example, we still want to find the GCF, but now we might have some variables in there. And it works the same way. So first we need to find what's the biggest number that goes into 9 and 36. And we can definitely look at this and do a prime factorization as well. But these numbers are smaller. So the biggest one is 9 because 9 actually goes into 36. So we know that 9 is part of our GCF. Now we look at the A's. We have A to the 4th and A. So how many A's are in common? Just 1. Now we look at the B's, B to the 3rd, B to the 8th. So how many B's are in common? B to the 3rd. So that would be our GCF here. Next they want us to factor completely. So now we might see some trinomials or even bigger polynomials, and we need to use those skills to factor out. So the first thing that you want to do is always look for a GCF in the problem. So now we have 3 terms here. So we need to see, is there anything that is common in all 3 of them? So first one is ABC, second term is BCD, and the third one is CDE. And we notice that there is a C in common. Now, is there anything else? Nope, the first 2 have a B, but the third one doesn't, so that doesn't work. The second and third one have a D, but the first one doesn't, so that doesn't count either. So C is the only thing common. So we can pull a C out, and then when we do that, what is left? So if I pull a C out of ABC, I'm left with AB. If I pull a C out of BCD, I'm left with BD. And if I pull a C out of CDE, I'm left with DE. So this would be the best that we could factor this. Okay, this one we want to factor as well. So first we want to look for a GCF, and there isn't one. So there's no GCF here. So now we have to see, can this be factored into 2 binomials? So remember way back when you did some foiling in order to, you had 2 binomials and you would FOIL them to multiply them, and then you ended up with a trinomial. So now we're going backwards. We have the trinomial, we want to go back to the 2 binomials. So if we look at this, a squared, the only way we can get a squared is a times a. And now we need to look at factors of 35 that add to 12. So we look at 35, we could have 1 and 35. We could have 5 and 7, and I think those are all the factors. So out of those, which ones are going to add to 12? And the answer is 5 and 7. And it doesn't matter where you put them. I could have put the 5 in the first one and 7 in the second one, and then plus. So a squared plus 12a plus 35 factors to a plus 7 times a plus 5. Okay, same thing here, we want to factor it, but now we have a little bit more involved because now we need factors of 8 and factors of 15 that give us 26 in the middle. So we need to look at our factors of 8, and factors of 8 are 1 and 8, 2 and 4, and factors of 15 are 1 and 15, and 3 and 5. So we could do a guess and check way of doing this and figure out which ones work. So we want two binomials. So let's try 2c plus 3. Actually, it should be a minus. And 4c minus 5. Let's see if that works. So the way to check is to FOIL. So if we look at the 2c and the 4c, that gives us the 8c squared. And the 3 times 5 gives us the 15. We need to see if we can figure out what is our middle. So that's when we multiply the outers and the inners together. So 2c times a negative 5 is negative 10c. And negative 3 times 4c is a negative 12c. Now, if I add those together, negative 10 minus 12, or subtract rather, then I get negative 22c. Now, that doesn't give me the negative 26. So, I need to try again. That is not going to be our factoring. So now in this case, we could rearrange them. So I could put the 5 here and the 3 over here and see if that works. And in this case, let's see. So it's still 8c squared and 15. Now we need the outers and the inners. So 2c times negative 3 is a negative 6c. And negative 5 times 4c is a negative 20c. And if I subtract those, I get negative 26c. So that actually does work. So this is our answer. 2c minus 5 times 4c minus 3. Okay, so first we always look for a GCF. So is there something that we can pull out that's common? Now if I look, the first one has T's and the second one has K's, so nothing there, but maybe the numbers. So does something go into 64 and go into 4? And 4 actually goes into both of those. So we're going to pull a 4 out of there. Now 64 divided by 4 is 16, T to the 6th. And then if I pull a 4 out of the second term, I'm left with k to the 8. Now we look at this part here in the parentheses and see if we can get something that is factored. Now it's not a trinomial, the middle term is missing, so that means our middle term is actually 0. So that means that when we do our outers and inners, they're going to be the same number, just 1 plus and 1 minus. So let's look at 16. How do I get 16? Well, one of the ways is 4 times 4. And then t to the 6th. Well, that could be t cubed and t cubed, because remember we add our exponents. And then k to the 8th could be k to the 4th and k to the 4th. So let's look at our outers and inners. What does that give us? Well, we have 4t cubed times k to the 4th. So that would be 4t cubed k to the 4th. And then negative k to the 4th times 4t cubed would be minus 4t cubed k to the 4th. Now if I subtract those, I get 0. So that is indeed what we are looking for. So our factoring of this is that right there. 4 times 4t cubed minus k to the 4th times 4t cubed plus k to the 4th. Alright, last one. Okay, this one has 4 terms in it. So of course, first we look to see, is there a GCF that we can possibly pull out of there, and there isn't. Not every term has an X and not every term has a number, so that's as good as it gets there. So now we might be able to factor by grouping. So what we want to do is we want to place parentheses around sections of this so that there's something in common we can pull out of there. Now, if we look at this, and this comes with extra practice, but notice that one of them has a plus and one has a minus. Now, our goal when doing this is we want to have something that is exact, 2 things that look identical. So in order to have that plus in there, I am going to change this to a plus a negative before I had put the parentheses. Okay, because subtracting a positive is the same as adding a negative, and you'll see why. So now out of the first one, let's see what we can pull out of there. So we pull a GCF out of the first set of parentheses. I can pull an x squared. Now what's left? So if I pull an x squared out of x cubed, I'm left with x. If I pull an x squared out of 6x squared, I'm left with a 6. Now the second one, I'm going to pull out a negative 4 as my GCF. So if I take negative 4x and divide it by negative 4, I'm left with a positive x. If I take negative 24 divided by a negative 4, I get a positive 6. Now notice we see that these two are alike. So what we're really doing is kind of looking at this part as a whole and pulling out a GCF, only this time our GCF happens to be an entire phrase. Now, so we pull an x plus 6. When I do that, what is left over? Well, I've got this guy and this guy, so I have x squared minus 4. So we factored it, yay! However, we're not quite done. Reason is because this one right here can actually be factored more. So we have x plus 6 times x squared minus 4, and now this one can break into 2 binomials all by itself. So what does that become? Well, x times x, and then 4 is 2 times 2, and we want 1 plus and 1 minus because our middle term is 0. So if we say 2x minus 2x, that gives us 0. So our final answer is x plus 6 times x minus 2 times x plus 2. So now that you've watched the recording, you're going to call me, text me, or send me a Skype message, and we will chat about this, and I'll ask you a question, and then you will be good for your quiz and finished with this lesson. Have a great day.